Hello everyone and welcome back. In this lesson, we introduce series and the sigma notation and explain how both series and the sigma notation are connected and how they work. The best thing to start with is an example. So let's suppose you decide to start an exercise program by walking for 20 minutes on day 1 and increase your walk time for 5 minutes each day for a 2-week period. Your walk time would look like this arithmetic sequence. We could call it AN, which represents our walk time for the 2-week period. Now, what if we want to find how much time we spent walking and decide to add these times together? Now we have 20 plus 25 plus 30 plus 35 all the way up to 85. And this now becomes what we call a series. A series, by definition, then, is the indicated sum of the terms of a sequence. So we may have a sequence AN here equal 20, 25, 30, etc. up to 85. And what we want to do now is add them together. And when we're adding them together, we call it a series. Series have the plus signs between them, between the numbers, notice. And a sequence will have the comma between the numbers. We can write series using the sigma notation. This sigma notation means the sum of. Now let's look at that example again. First, we're going to want to find the nth term of this sequence. Remember, to find the nth term, what we do is that we look at our sequence, we try to make a table of differences and find the common difference, and then we use our formula to write down the nth term. So here we can see that the common difference between 20 and 25, subtracting here, 25 minus 20, we get 5. 30 minus 25, we get 5. So our common difference here is 5. And we can use the formula AN equal to A plus N minus 1D to write down the nth term of our sequence. So here we have that it would be 5. Sorry, not 5, 20. 20 is our first term, so 20 plus 5 times n minus 1, according to the formula that we have here. This gives us 20 plus 5n minus 5, which gives us 15 plus 5n for n equal 1, 2, up to 14. Now we can write this now in terms of using the sigma notation as a series. And what we do is that we write our sigma notation. There are 14 terms. We start at 1. We write that here. And then the number that we stop at the top. So from n equal 1 to 14. So this would read the sum of 15 plus 5n from n equal 1 to 14. And this is how we write our series. This is the sequence. Sn is equal to 15 plus 5n. This is the sequence. And this over this side is the series, the sum of 15 plus 5n from n equal 1 to 14. And this is how we write it. Series can be finite or series can be infinite. And the difference is very simple. If a series is finite, it means that its domain is finite. So here in this sequence, for example, we're moving from 1 to 14. There are 14 terms. And so here we are moving from 1 to 30 terms. And because of that, it's finite. So it's finite because its domain is finite. Some series, however, are infinite. And that happens simply because the domain is infinite. So from n equal 1 to as far as we can imagine. From n equal 1 to infinity, the sum of 3n minus 1, it's infinite because its domain is infinite. All right, so series can be finite or infinite. What we're going to do now is that we're going to write these two sequences using sigma notation. Now, if you want to guess what this sequence is, 1 square plus 2 squares plus 3 square plus 4 square, it looks like it's saying n square. So this would be an is equal to n squared. And we can write that using sigma notation. Notice that it starts from 1, but that it doesn't have an end. The dot would indicate that it continues forever. And so we'd say from n equal 1 to infinity. And what we're going to be doing is adding n squared. For this one, however, we have 1, 2, 3, 4, 5, 6, 7 terms. So 7 terms would mean that it's finite. And so we could say, right in the sigma notation, from n equal 1 to 7, but we're going to need a formula for this. So here you could notice that the common difference is 2, and therefore our sequence an is going to be 2n plus 1. So 2 1's 2 plus 1 3, 2 2's 4 plus 1 5. This is the formula for it. And then our series is going to be written as the sum from n equal 1 to 7. 1, 2, 3, 4, 5, 6, 7. So that's where the 7 comes from. 2n plus 1. So we can take sequences and we can write them as series. We can take these numbers that are written out this way, expanded, and contract it this way, write it in using the sigma notation. Or we can do the opposite. We can say, for example, we have from the sum from k equal 1 to 5 of 2k minus 2, and we want to write that out in terms of writing the original terms. So if we substitute 1 into this, then 2 times 1 is 2, 2 minus 2 is 0. And put in our plus. If k is 2, then 2 2 is 4, and 4 minus 2 is 2. Plus, if k is 3, then 2 3's are 6, 6 minus 2 is 4, and so you can see where this is headed, 0 plus 2 plus 4 plus 6 plus 8. 1, 2, 3, 4, 5 terms. And so having this formula here saying the sum of 2k minus 2 from k equal 1 to 5, this is actually what it means if you want to write it out. And this one is quite simple. If you want to write out the sum of k squared from k equal 1 to 4, then we simply write it as 1 squared plus 2 squared plus 3 squared plus 4 squared. There are some very simple properties of series that we need to be familiar with, such as the sum from I equal 1 to n of 3k, that is when we're multiplying our variable here by a constant, that it can be split in 2. So for example, if we have 3 plus 6 plus 9 plus 12, for argument's sake, then we can factor out a 3 from this and say 3 times 1 plus 2 plus 3 plus 4. And so we can demonstrate it with a simple example that the sum of 3 plus 6 plus 9 plus 12 is the same thing as the sum of 3 times 1 plus 2 plus 3 plus 4, etc. Which means that if we have this, we can easily separate it. The sum of 3k from I equal 1 to n, we can separate it as 3 times the sum of k, for example. Same thing here. The sum of an plus bn, we can break it in two and write it as the sum of an plus the sum of bn. Notice that it's written over the same domain from 1 to n. And so, for example, if we're summing n squared plus n from n equal 1 to 3, it's the same thing as saying the sum from 1 to 3 of n squared plus the sum from 1 to 3 of n. And in terms of numbers, all that it would mean is 1 squared plus 1 plus 2 squared plus 2 plus 3 squared plus 3. And it will give you the same result as if you had the sum of 1 squared plus 2 squared plus 3 squared plus the sum of 1 plus 2 plus 3. So these are very simple formula that you must be aware of, that if you are summing a product here, you can always break it in two and say 3 times the sum of. And if you have a sum, you can always write it as the sum of its differences. This has been our introduction to series and the sigma notation, and how to use the sigma notation to write series, or how to write out series that are already written down with the sigma notation. That's it for now. Remember to keep practicing, and that you can find practice material on our website at the Additional Mathematics on csigmathtutor.com. If you haven't subscribed, please remember to do so. Thank you for watching, and continue to work hard.